Assalamu alaikum. So let's say we have a difference equation that represents a system. So in this video we will find the value of y or the response of the system using this matlab code. Okay, so first of all, so in this video it is the input. So here xn is the input. So we will first take input as equal to delta and then step, and finally we will use a sinusoidal signal, and then we will verify that our filter function is working correctly or not. Okay, so let's start. Let's first work with the theory. So this is the difference equation and the coefficients. So I have to write the first the coefficients of x, which I will call b. So the coefficients of x are, you can see that the coefficient of xn is 1 and the coefficient of xn minus 1 is 0.2. So the b matrix is equal to 1 and 0.2, and then I have to make a matrix, and a is the coefficient of y. So the coefficient of y is yn is 1, then yn minus 1's coefficient 0.6, and then 0.002. Okay, so now we have to use a filter function. So first we have to write the coefficient of x, secondly we have to write coefficient of y, and then we have to write the input. We have to write the input where the input is equal to x. And if I make this function, if I make this built-in function, this is the built-in function of MATLAB. Let me go to the MATLAB's. Okay, so this is filter, which takes b, a and the input, and it will give you y. So it will give you y. Okay, so in this video we will use this. Oh, let me tell you one more thing. Let's say this is your input. This is your input, which is actually equal to x, and it is the time index for input, and it starts from -10 and ends at 20 for my for this video, for my code. And from here I will get the output. This y is the output, and using this filter I will get the values from -10 to 20. That means if the input's time index is -10 to 20, by using filter I will also get the signal's value from -10 to 20. Okay, so that means time index of input and time index of output is same. So by remembering this formula, remembering this thing, let's go to our code. So this section generates a delta function. So if I run this code, you will see that this is a delta function. This will be my input. My another input is step, which is actually un. So if I run this code, this is u. I have told you how to generate this delta, step, and the sine in the previous video. So this is the sine function. In some video of this playlist you can watch that. Okay, so this is sine and un. That means it starts from 0, and before 0, when n is negative, as the signal's value is 0, as you are multiplying sine with un. Okay, so generating the inputs, I have generated this 3 input signal, and then first of all I will find the impulse response of that system. Let me tell you about that. This is a system. Let me write it again here. So this is the difference equation. So this is a difference equation, and this difference equation represents a system. So let's say this is a system, and if I input x to this system, I will get y. Okay, and the impulse, let's say the impulse response of this system is hn. Now if I input delta to this system, as its impulse response is hn, then I will get hn as output. So this is a way to find the impulse response of any system. Just we need to set input is equal to delta n. So if I pass delta n to the system, I will get the impulse response by theory. So in this case, first of all, this is my equation. So I have made the coefficient of y, then b is the coefficient of x, then input is our delta function, and then I use the filter function. Don't forget that first you have to write the coefficient of x, then coefficient of y, and then you have to write the input. And then if you plot this, and as output you will get h, right? Like this, your input is delta and your output is h. So if you run this code, you will get this is h versus n graph. So this is the impulse response of this system using filter function. Okay, now let's walk to here. So finding step response, that means now you have to input a step function which is u, and now you have input this thing in the inside the filter. So at output you will get the step response. That means if this is the system whose impulse response is h, and if you now input un, then as an output you will get, now let's say what we have written here, this is the step response. This is the step response. So now your output y is equal to step response. So let's plot this step response. You see this looks like un. First you have a transient period, and after the transient period ended up, you get a steady state period, and this value is 0.7, not 1, right? Okay, this looks like step function, but you see the value is different. Okay, so now let's talk about this sinusoidal response. This is the sine signal input, and similarly if you pass it to the filter function, you will get sinusoidal response. Okay, so this is the sinusoidal response of that. This is the output. This is the output after you pass this. This looks like the input, but this is not exactly equal to the input. Okay, why? Because let's go to our sinusoidal signal. So where is our input? So this is the input. This is the input. You see the input's amplitude is 0.5, but the amplitude here is not 0.5. Amplitude is not 0.5. You see, that means this is the output. Looks like input, but actually not input. Okay, so I have obtained the sinusoidal response, and now I will check. I will find this sinusoidal response, that means y, in different way. Okay, so I have find using filter, but now I will find it using convolution. So you know the theory that if you pass x to the system, then y is simply is equal to hn convolution of xn, right? So if you pass delta n, then what will be y? Y will be delta n convolution of hn, and if you convolute anything with delta, you will get that thing. And that's why if I pass delta n to the system, I obtained hn. Similarly, if you pass sinusoidal signal, let's say your input is a sine signal, so the output will be that hn convolution of that sine signal, right? So now we have to convolute hn and sine n, and let's see that our convolution matches with the filter with the output that we obtained from the filter. Okay, so this is the convolution. This is the convolution of sine signal and h, and where we get this h? We get this h from the previous step. From here we get this h, right? Okay, so let's use this h here, and if I run the simulation, okay, so let me do one thing. This is the output using filter. So if I run this code, this is the output using filter, right? and now this is the output using convolution, and let's see these two matches or not. So when x is equal to 5, you have 0.37. this is the output using filter, and here you have the output using convolution, and when x is equal to 5 is 0.37. okay, let's check with another point. When x is 19, output is minus 0.09, and here when x is 19, okay, two matches. Okay, let me work with different signal. Okay, let me do this in the in the next video or next some video. Okay, so what is the summary of my this video? The summary is, we can find h by using filter function. B is the coefficient of x, it is the coefficient of x. A is the coefficient of y, and then you have to write the input. So x is the input, sorry, it's delta, actually it's delta, the input is delta, and then you will get h. Now using this h you can find, let's say x is any signal, any input signal, and now you want to find the y for this kind of x. So we have two ways. How? First way is to use filter. First a coefficient of x, coefficient of y, then the input. And the second is just simply convolute this input with h, or you can write it as convolution of h x, the order doesn't matter. So if you do this you will get y. So this is all for today. Thank you.